All right. So for question one, we have the process from 1 to 2, which is the internal energy minus the second internal energy minus CV. And then we have in parentheses the first temperature minus the second temperature, and then this is what we get when we calculate it. I can write out the formula here. The initial. I don't know if you can see. Yeah. D1 minus D2. All right, and then same thing goes for process 2 to 3. The second internal energy minus the third internal energy, and then we have the same formula. Yeah, and then the second temperature minus the third temperature, and then this is what we get when we calculate it. From process 2 to 3, from 3 to 4, my bad. So we do the third initial. I'm sorry. I'm sorry. The third initial internal energy minus the fourth internal energy. Same formula. 4.187, and then the third temperature minus the fourth temperature, and this is what we get when we calculate that. And then at state point 4, x4 is equal to 0.2, and then from t is equal to 120. So at 120 degrees Celsius, the initial final is 503.60 kilojoules over kilograms, and then the UFG is equal to 25.3 kilojoules per kilogram, and then the initial, this is not a PE symbol. So the initial, so when we calculate that, this is what we get. All right. For problem number 2, we have P is 1 bar, which is equal to 100 kilopascal. P2 is equal to 1,500 kilopascals. The first temperature is 300. T3 is 300 as well. From 1 to 2, we calculate. There's the formula we're going to use, which is the second temperature over the first temperature is equal to the pressure, the second pressure over pressure 1. And so this is what we get when we use that formula. This is what we get for the second temperature when we calculate that. And then to calculate the the velocity, I think. I'm sorry, I got a little confused. So from 2 to 3, the constant volume process. So we have the kilopascals, 1,500 kilopascals, and this is the graph for. Oh, I'm sorry. here is the two graphs for the first problem. Yeah, we got the 10 bar, the 3 bar. Wait, I forgot the one here. 1, 2, 3, 4. 1, 2, 3, 4. This is the graph for the second problem. 1,500 kilopascals. This is supposed to be 2, 3. And then we have 2, 1, and then 3, and that's the and okay, so we use the third pressure over P3 over P2 is equal to the third temperature over T2. And then to calculate that, we can just use this equation, and then P3 is equal to 691.93 kilopascals. Okay, and then from 2 to 3 is equal to CV theta T, and then same thing, so 0.718, 0.718, and then we use that same equation, and when we calculate that, we get this. And then this is the temperature. This is the second temperature, the first temperature. So